Hello friends, this video on Ray Optics part 19 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 18 before going ahead with part 19. So now we often call an optically rarer medium as rarer medium and optically denser medium as denser medium. So you will see that most of the time we will talk like this, that a rarer medium, a denser medium, like that. So we often do not use the term optically, but what we try to say is optically rarer and optically denser medium. So it says that a ray of light moving from a rarer medium to a denser medium always bends towards the normal. Why is it so? So this is a standard fact that a ray of light, when it moves from a rarer medium to a denser medium, it will always bend towards the normal. Now let us see why is it so. Suppose we have two medium, 1 and 2. This is the normal drawn to the boundary of the two medium. Let us suppose this is the ray of light which is incident on the interface. So now how will the refracted ray go? Now from Snell's law, what do we know? From Snell's law we know that sin I by sin R is equal to n to 1. Now if we assume that light moves from, let us suppose light goes from medium 1 to medium 2. If light goes from medium 1 to medium 2, then sin I by sin R is equal to n to 1. That is refractive index of 2 with respect to 1. That is the refractive index of the medium where the light goes to the refractive index of the medium from where the light goes. Right? Okay. So now we are saying that in this case the light is moving from a rarer medium to a denser medium. So this is a rarer medium and this is a denser medium. So this n21 is nothing but n2 by n1. Now since this medium is rarer, that means n1 will be lesser than n2 in this case, because refractive index of rarer medium will be lesser than the denser medium. So this we can say that sin I by sin R is equal to, this is n2 by n1. So what will happen to n2 by n1? n2 is greater than n1. So that means this will be greater than 1, which is n2 by n1, that is greater than 1, because n2 is greater than n1. Right? So we can say that sin I by sin R is greater than 1. That means sin I is greater than sin R. So we can say that I is greater than R. That means the angle of incidence is greater than the angle of refraction. So now when will the angle of refraction be greater than the angle of incidence? Let us suppose if the ray would have gone like this, that is along the same path without bending. In that case, this angle will be the same as angle of incidence. Now we want that angle of incidence remain greater than refraction. That means we want the angle of refraction to be lesser than the angle of incidence. So for that, the ray should get reflected somewhat like this, so that this angle decreases. So this angle will decrease only when this refracted ray bends towards the normal, right? Therefore, refracted ray bends towards normal. Right? Now let us look at the next one. It says that a ray of light moving from a denser medium to rarer medium bends away from the normal. Here also let us look at the same scenario. Let us suppose this is medium 1, this is medium 2, and this is the normal. This is a ray of light making an angle I. But in this case it says that this is the denser medium and this is the rarer medium. That means here n1 is greater than n2. So n1 is greater than n2 means n1 by n2 is greater than 1. Right? So again here we apply Snell's law. So from Snell's law we can say that sin I by sine r is equal to n21, which is equal to n2 by n1. Now n1 by n2 is greater than 1. Therefore n2 by n1 will be less than 1. So we can say that sine I by sine r is less than 1, or we can say sine I is less than sine r, or we can say I is less than r. So in this case, this angle of incidence should be less than the angle of refraction. Therefore, the ray should go away from the normal so that this angle increases. Right? If we want this angle to increase, this ray has to move away from the normal. If we want angle of refraction to decrease, then the ray has to bend towards the normal. So you understood the logic why it happens that when a ray of light moves from a rarer medium to a denser medium, it always bends towards the normal. When it moves from a denser medium to rarer medium, it always bends away from the normal. Please understand these reasons behind why things happen this way. Instead of just remembering that, okay, if a ray goes from rarer to denser medium, it has to bend towards the normal and vice versa. Don't remember it like that. Please understand why does it happen in this way. Okay, so what happens? Rarer to denser, that means it will bend towards the normal, right? Okay. So in just as a memory tip, you can remember it like this. When you go from a rarer medium to denser medium means something which is very dense, a place where it is which is very much crowded, so many people are there. So when the ray of light enters a crowded area, it feels scared. It doesn't want to be alone. So it tries to come near the normal. It wants to stay with the normal. So when it enters from rarer to denser medium, it tries to come closer to the normal. Therefore, it bends towards the normal. Whereas when it enters from denser medium to rarer medium, it is entering a medium which is less crowded. So it is not afraid of, and it moves away from the normal, and it can stay alone easily, right? So when it enters from rarer to denser medium, it gets scared and it wants to stay with the normal. So please do not get confused and remember these steps. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.